Hi, so today I'm going to do the solutions to the topic 16 additional problems. Um, the first problem, the first four problems say determine if each system of linear equations has one and only one solution, infinitely many solutions, or no solution. And then find all solutions whenever they exist. So the first problem, so let's write this up here, is topic 16, additional problems. So the first question is x minus 3y equals -1, and 4x plus 3y equals 11. And the question here really is about solving for x and y. And when we have two variables, usually the best way to do this is with substitution. But once in a while, you'll notice that it's really all set up for elimination. So here we have minus 3y plus 3y. So if we just add these together, we're going to get rid of the y variable. So let's just add these up together. So this is an elimination approach. So we add these together and we get x plus 4x is 5x, minus 3y plus 3y is 0, and -1 plus 11 is going to give us 10. So dividing by 5 on both sides, we get that x is equal to 2. Once we know x is equal to 2, we can substitute into any of these problems. So I'm going to substitute into the first equation, and I'm going to say 2 minus 3y is equal to -1. So subtracting 2 from both sides, I get that -3y is equal to -3. And then dividing both sides by -3, I get that y is equal to 1. So my answer is y equals 1 and x equals 2. Now I can check either one of these. I can check these answers back in the original equation. So as a check, I can always go back and say, well, this 2 minus 3 times 1 equal -1. Well, that's 2 minus 3. Does that equal -1? Yes. Right? All right, so now let's go on to number 2. My eraser. Okay, so problem number 2 is, hold on one second, let me get it. It is 2x minus 4y equals 5. And the second equation is 3x plus 2y equals 6. All right. Now, what we can do here is we can go ahead and try and solve it with substitution, or we can try elimination. So again, I'm looking at minus 4y and plus 2y. So I'm just going to make my life easy and go ahead and multiply the second equation by 2. Right? Sorry, multiply the whole thing through by 2. And that's going to give me 6x plus 4y equals 12. And then I'm going to write the first equation below that, and I'm going to get 2x minus 4y equals 5. So if I do this, I can add these together now. I add down. I make sure I line up my variables. So I have x over x, y over y, and I'm going to add the coefficients. And here I get 8x, 4y minus 4y is 0, equals 12 plus 5 or 17. So x equals 17 bits. Now that I know that, I can go back into any of these equations that have an x and y and get what y is. So I'm going to go back and I'm going to substitute. Let's see, what's the easiest one? Well, not sure. Looks messy no matter what here. So I'm going to use the very first one. And I'm going to say 2 times 17 over 5 minus 4y is equal to 5. Okay. So 2 times 17 is what? 34 over 5 minus 4y equals 5. So I'm going to multiply everything through by 5 because I don't like fractions. So multiply everything through by 5, and I get 34 minus distributing this 5 through, right? Minus 20y equals 25. And now solving for y, I get subtracting 34 from both sides. I get minus 20y is equal to minus 9. So I'm going to just give myself a little space up here. And I'm going to say y is equal to minus 9, divide both sides by negative 20, divided by negative 20, or 9/20. Okay, so my answer is x is equal to 17/5, y is equal to 9/20. Okay, now if we wanted to just double check that we did this right, we would pick one of these equations and plug in to make sure. So I'm going to go back and just plug in just to check my math. Make sure I didn't make a math error along the way back in the first equation. So I'm going to say 2 times 17/5 minus 4 times 9/20. Does that equal 5? Okay, well, here we have 34/5, and 4 goes into 20 5 times, so it's minus 9/5. And the question, is that 5? Well, 34 minus 9 is 25/5. And yes, that is 5. So we did it right. Okay, now on to problem 3. Problem 3 says, x plus 4y equals 7. And a half x plus 2y equals 5. Right. So I'm going to do this one with substitution, just to mix it up. And part of the reason I'm going to do this is because I see just a plain x here. And that makes me think that I can do substitution fairly easy. So via substitution, I'm going to solve for x. So I get x is equal to 7 minus 4y. Because in order to do that, right, all I did was take this 4y and I moved it over. So I made it a minus 4y. Now that I have that, I'm going to go back and substitute into the other equation. So now I have to sub into the other equation. So I'm going to have 1/2, and instead of x, okay, I'm going to put in the substitution right here. So I pay 7 minus 4y is another way to say x, because I just now and previously said they were equal. And then plus 2y equals 5. All right, so this is 7/2 x, and 1/2 times minus 4 is minus 2y plus 2y equals 5. When I get here, minus 2y plus 2y, they cancel. So I get that 7/2 equals 5. But that's false. That's impossible. So this has no solution. And I should have said in those other problems, they each had they had one unique solution. Okay? Here we have no solution. All right, now let me go on to problem number 4. Okay, problem number 4 is x plus 2y equals 7. And 2x minus y is equal to 4. And I'm going to do this one by substitution as well. And this time I'm going to, remember, you can always choose which equation and which variable you want to work with. So I'm going to choose to solve for y in second equation. So the way I'm going to do that is I'm going to add y to both sides, and so that way I'm moving y to the right, and I'm going to subtract 4, so I'm moving it to the left. So when I end up, and the reason I'm kind of suggesting you do this in your head is you kind of want to start to be able to get a little faster with this algebra manipulation, right? So the way this comes down, and I'm going to switch to blue because I think it's going to be more visible, is then I get that y is equal to 2x minus 4. Now, if you're making mistakes, if you've got a different answer on that, don't do this fast track thing that I'm doing. All right, so make sure you work through the details and get it right. Okay, so now we have that 2x, that y, another name for y is 2x minus 4. So we're going to use that up in the previous equation. So in first equation, we're going to say x plus 2, and this is where we're going to substitute 2x minus 4 for y. And this is all equal to 7. Right, so now we just do the simplification. We're going to distribute the 2. We have x plus 4x, and then minus 8 is equal to 7. So now we combine like terms, and we're going to get and add 8 to both sides. So here we're going to get 5x is equal to 15, dividing by 5. We're going to get that x is equal to 3. Now that we know that, we'll substitute that back up into this equation. So we get that this is 2 times 3 minus 4, which is 6 minus 4, which is 2. So the answer is x equals 3, y equals 2. And that's the one unique solution to problem number 4. Okay, let's look at problem number 5. It says, formulate but don't solve the problem as a system of linear equations. So there's the coffee shop. It sells a coffee blend. And it's made of 2 forms of coffee. One costs $5 a pound, and the other costs $6 a pound. If the blended coffee sells for $5.60 a pound, find out how much of each coffee is used to obtain the desired blend. Assume the weight of the blended coffee is 100 pounds. Okay, so let's say A is the amount of the first coffee used in the blend. First coffee used. And B is the amount of the second coffee used. All right. And we're going to make 100 pounds of this coffee. So A plus B is going to be 100 pounds. So total weight of coffee. All right. Now, if I am going to sell it for $5.60 a pound, so it's $5.60 per pound. That means 100 pounds costs, I'm going to move the decimal 2 to the right, so it's 560 times 100, or $560. Okay, So the amount of A, and it cost me $5 a pound. So I'm going to say $5 times the weight of A plus $6 times the weight of B is going to be 560. So I have these two equations, A plus B equals 100, and 5 times A plus 6 times B equals 560. So the tricky part about that problem was that you had to convert this 560 per pound to what it applied to and meant in our word problem, where we had 100 pounds of coffee that we were using to solve the problem. Okay, so hopefully that was clear, and we'll see you in boot camp, maybe.